7.3, last day, okay? So most books and online and everything, they call these washers. This is the washer method. I call them donuts, so I'll explain both. Imagine the region below spinning around the x-axis. So this whole thing is going around and around that x-axis. So can you imagine why I would call that a donut? Because it's like this weird, not fluffy, but like kind of angular donut, right? There's like this big Aries part in the middle. And then the reason they call this washers, if you go around and around, imagine slicing a donut this way. So if you look through like the side of the donut and then you slice it and then you slice it, slice it, slice it, what you would see is this circle and then this empty circle inside. So it would be filled and then it would be like empty inside, right? So it's empty in the middle of that circle when you slice and get cross sections. So that's why they call it washers, because that's what a washer is. And then that's why I call them donuts. So how would you get the volume of a donut? Well, you could take the volume of the whole thing and then subtract away the volume of the middle, right? So that's what I'm doing here. Basically, you have this big radius that goes around and around and around, and then you have this little radius that you subtract away. And then now you're left with the shaded region going around and around and around. So it starts off with this formula. So the volume using the washer method is going to be pi r squared minus pi r squared, because you have a big radius and then you have a little radius. So you're subtracting like the area of a big circle minus the area of a little circle, and then you're doing that many, many, many times to get a volume. So how can we rewrite this? Well, we can go ahead and basically factor out the pi, and we can basically factor the integral. So something like this. So pi integral of, and then big R squared minus little r squared. So it's the same as we had before, but now it's pi r squared minus pi r squared. So we just write it like this, as one integral. So how would that work in a problem? Well, let's say you had something like this. Let's say you have no calculator, because sometimes you're not going to be able to use a calculator or Desmos or anything like that, because not allowed. So you'd probably have to solve it first, right? And then find some points of intersection to help you graph it. So I'm going to show you the graph and the volume all at the same time. So here is the graph. It looks something like this. So ignore all the blue stuff, you know, whatever. So you see the pink, right? So that's how you would graph your 2 points. And then you know that the parabola goes up 1, so it starts right here, up 1. And then so you draw your parabola, you draw your y equals 4, you shade in the middle, so you shade in the blue part. Okay, you take that blue part and you're going around and around the x-axis. So if you're going around the x-axis, you're going around this axis. So then I tried to draw the volume for you and see if that makes sense. So that would be something like the volume. So if I went around and around from there, if I went around and around from there, around and around from here, and then I had this same shape go all the way around. So this is almost like a cross section of the volume, because you know it'd be hard to really draw that volume. So this is generally how I draw it, and you can kind of imagine it's like if you took a cylinder that was filled up and then you just deleted this hourglass in between. Right? So that's basically what's happening. So the solid part is the shaded part all the way around, and then there's this like empty hourglass inside. Okay, so how do you get the full part without the empty part? So the full would go from here to here as your big R, right? So from the very furthest point of your area to the axis of rotation, I'll say that again, the very furthest point of your area to the axis of rotation, whatever you're rotating around. And then the little r is going to be the closest point of your area. So this is the furthest point. This is the closest point to your axis of rotation. Okay, so then this is the top minus bottom. This is the top minus bottom. I go ahead and write out what is my top minus bottom. Well, for big R, it's going to be from here to here. This is y equals 4. This is y equals 0. For little r, it's from here to here. This is y equals something squared, and this is y equals 0. So here's my minus, minus, top minus bottom. And then I set it up. So maybe something like this. So pi from -3 to 3, because I'm going from here all the way to here. This is in terms of x. I'm going around something horizontal, so it's in terms of x. And then I literally plug in my big R and my little r. Do I need the -0? No. Can I have it? Yes. It's up to you. So big R squared minus little r squared. Done. Okay, so for the next one, I don't really think we need to do part 1 where you have to solve it, because you should be able to graph this. So we're going to take a look at the graph, and it's going to show everything, but just focus on the pink stuff and then look at the whole volume. I don't know if you can do that, but you're going to try. Okay, so the pink stuff I drew because I knew a parabola, a perfect parabola goes to 2, 4 and 1, 1, and right here, sorry. And then y equals 2x. So that's going to go 2, 4, and then it's going to go through here. So that's the line. I shaded that in. So here's my original area, that blue area. That blue area is getting rotated around the y-axis. If I go around and around this way, if I take that blue and go around and around, you can kind of imagine this as like a tulip, right? So kind of like a tulip all the way around. It's nice and curved around the sides, and then it's like you're taking the cone out from the middle of this shape, which is not a half ball, but something like that. So if you take this whole thing as a solid figure and then you just subtract the cone. Okay, so because I'm going around the y-axis, that means that I'm going from the furthest point of my area to the axis of revolution, and that's my big R. From the closer point to my axis of revolution, that's my little r. Okay, I did change these to x equals, and I also changed this one to x equals because this is going around a vertical line, and that means I'm going to be in terms of y. All right, so what is my big R and little r? So you're going to figure that out first. It's a right minus left and a right minus left. What is your right minus left? For big R, it's the parabola, and when you solve for x, it's a positive root y. This part is the negative root y, technically. So positive root y minus 0. What about this one? It's the line minus 0. And the line, when you solve for x, is y over 2. So y over 2 minus 0. And then you just write it in. So from 0 to 4 on the y-axis, so pi 0 to 4, big R squared minus little r squared, and then in terms of y. Okay, how is this different than the next question? The next question is exactly the same, but instead of going around the y-axis, instead of going around here, we're going around x equals 2. What is x equals 2? X equals 2 is a vertical line still. So now that blue part, if it goes around here, can you imagine what that would look like? That would go like this, and then this part would kind of go like that. It would kind of look like a teepee, right? So something like this, right? So it's almost the same thing, but it's not exactly the same thing, okay? And it's not going to be the same answer if you put it into the calculator either. All right, so now this is a little different. We're going from the furthest to the axis of revolution, the closest to the axis of revolution. My right minus left and my right minus left are not the same as this one. What is your right minus left? For big R, the right side is x equals 2 for both, x equals 2. The left for big R is the line. The left for little r is the parabola, which becomes a root y, positive root y. Because again, negative root y is over here. This is positive root y. Okay, so then you just plug it in. So it looks, similar, but it's not the same. It is not going to give you exactly the same answer either, okay? So 0 to 4, and then you just plug it right in, plug it right in. The big thing is going to be you're going to forget to write pi and you're going to think you have the right answer, but you don't. You're going to forget to write squared and you're going to think you have the right answer, but you don't. So just be really, really careful. Okay, so on the back, you guys have some practice. So I'm just going to remind you about this practice, okay? What do you do? How do you find solutions on a graphing calculator? You can plug this in, you can plug this in and find the intersections. Or you can do something else. So I'll remind you. So your answers are these. We'll talk about that in a second. So plug it in, plug it in. So y sub 1, y sub 2, calculate the intersections. That's calculate and then like number 5, right? Or you can set these equal and then you can solve on one side, get the other side to equal 0, and you can use one equation, so just use y sub 1, and you can calculate zeros. It's up to you. Either way, you get these two very important x values. We really only care about the x values, I'll be honest, okay? So that's what we really care about. Okay, so you're going to just do it. Get these x values. You try it. And then we'll check it. You do it. Okay, so it's this one and this one. You do it. So we've done it a couple times together already, but this is just a review. Okay, what about this one? For this one, you put it in and it says solutions. This is different, right? This is two things. You're setting them equal to each other and you get 2 points. What about this? This means zeros. So plug this into your calculator. Now you're finding zeros. So you should get these 3 zeros. These 3 x values are very, very important. Remember that you have to eventually store these into your calculator. So once you find one, you quit and then you store. And then you find the next one, you quit and then you store it. So store it as like A, B, and C. And then you can use them later, right? Okay, so the next part on the right side, I just want you to basically it's not that I want you to copy it, but I want you to be able to understand it and, see what I'm doing, okay? So I'm not saying you have to do it all right now, but you should be able to do it. So here's just some more examples, okay, that I used to do with other classes, so I'm gonna do it with you. So how would we do something like this? So they actually give you a graph and they say, okay, that with x equals 0. So I shaded in it. It was shaded, but it's hard when I when I copy it. So I shaded it in blue. So the original bounded area is in blue. And then it says, now we're going to rotate that around the x-axis. So if I rotate around, it kind of looks like that, right? So it looks like this football-y shape. How would you get the area of that? All right, well, that's a pi r squared. So there's no hole, there's no donut. So it's a pi r squared. So this is just like general review. And then you're going from -1 to 1 because we're going around the x-axis, so that's something horizontal. You put this into the calculator, you get something. Okay, so this one is different. This one, you take that blue shape and you're going around and around. So when you go around, basically you have this whole empty space inside. That's how you know. I want you to draw it so you know that you have an empty space inside. So see how this is pi r squared? This is pi r squared minus r squared, right? Because pi r squared minus pi r squared, technically. So r squared minus r squared. How did I get this? From the furthest, which is the line, all the way to 0, to, what is that, y equals 0. So the furthest minus 0. And then the closest is the parabola, so the parabola minus 0. So that's why it's big R squared minus little r squared. If you plug that into the calculator, you get that. I think you should plug it in one time for the homework. So you can just do the setup for the homework, but you should plug it in one time. Make sure that you plug it in correctly, okay? Okay, here's the last two, so you can just take a look at some more. You can tell this one, when you're going around a y equals -1, so y equals -1 is what I'm going, they tell me, that's what I'm going around. So I count down and then I count down some more. So it's kind of like this blue part goes down and becomes this, and it goes back around and around. So again, I have a pi, big R squared minus little r squared. The x values start at 0 and go to 1, so 0 to 1. From furthest away to my y equals 1, so it's going to be minus a negative 1, which is plus 1, okay? So this one right here, that's the root, right? Doesn't that look like a square root? So that's big R, from the root to the negative 1. So this minus negative 1 is going to be root plus 2. That's my big R. The closer one is from here down to the negative 1. So this one minus a negative 1 is x squared plus 2. Okay, so then the last one, very, very similar, except you're going around a vertical line. So then you have in terms of y, make sure you're always in terms of y. You're between a negative 2 and a positive 1. Look at the blue part to tell you negative 2 to positive 1. From here to here is the parabola minus a negative 2. Minus a negative 2, there you go. And then from the line to negative 2 is y, and then minus a negative 2. All right, so give that a try. Bye, guys.